Here we do some examples of quantifying compounds in various ways using conversion factors. Again, we will read to determine the units involved. We will do the chemistry by asking what is in a mole, and we will do the math by constructing a conversion factor. We will need to pay attention to whether we are dealing with quantities associated with the compound or quantities associated with the individual elements. Our first example asks how many grams of hydrogen are contained in 7.25 moles of ammonia, NH3. In reading the problem, we see that it is asking us to convert from moles of compound to grams of hydrogen. We use our chemistry knowledge to ask what is in 1 mole of compound. Of course, there is 1 mole of ammonia in a mole of ammonia. The 3 in the chemical formula tells us there are 3 moles of hydrogen, or 3 times the molar mass of hydrogen. 3.024 grams of hydrogen in 1 mole of ammonia. To solve the problem, we start with the 7.25 moles of compound given and construct a conversion factor with moles of compound on the bottom and grams of hydrogen on the top. Calculation gives 21.9 grams of hydrogen. Here again is our solution. Some textbooks and instructors will teach a multi-step calculation to solve this problem. They will first take the 7.25 moles of ammonia and convert to moles of hydrogen using what is sometimes called the stoichiometric factor from the chemical formula. They will then, in a second step, convert the moles of hydrogen to grams of hydrogen using the molar mass from the periodic table. This gives the same numerical result, 21.9 grams of hydrogen. Both methods use the same chemistry knowledge, the fact that there are 3 hydrogens in the formula and the molar mass of hydrogen comes from the periodic table. But there is some reason to believe that the fewer steps you take in a calculation, the fewer mistakes you are likely to make. We have presented a method for a 1-step calculation, and we will use it in the rest of our examples. You can use whatever is most comfortable for you. Our next example asks how many moles of sodium are contained in 32.2 grams of sodium sulfate. In reading the problem, we see that it is asking us to convert from grams of compound to moles of sodium. We use our chemistry knowledge to ask what is in 1 mole of compound. Since we are starting from grams of compound, we need the molar mass of the compound. Adding the contributions of each element, we find the molar mass is 142.05 grams per mole. The 2 in the chemical formula tells us there are 2 moles of sodium in 1 mole of compound. To solve the problem, we start with the 32.2 grams of compound given and construct a conversion factor with grams of compound on the bottom and moles of sodium on the top. Calculation gives 0.453 moles of sodium. Our next example asks how many grams of hydrogen are in a sample of C8H18 that contains 0.600 moles of carbon. Reading the problem shows we need to convert from moles of carbon to grams of hydrogen. We use our chemistry knowledge to ask what is in 1 mole of compound. The chemical formula tells us there are 8 moles of carbon in 1 mole of compound. Since there are 18 hydrogens in the formula, there is 18 times hydrogen's molar mass, or 18.14 grams of hydrogen in a mole of compound. To solve the problem, we start with the 0.600 moles of carbon given and construct a conversion factor with moles of carbon on the bottom and grams of hydrogen on the top. Calculation gives 1.36 grams of hydrogen. Our final example asks how many individual chromium ions are in a sample of CrCl3 that contains 4.50 grams of chlorine. Reading the problem shows we need to convert from grams of chlorine to individual chromium ions. Asking about individual ions or atoms instead of moles of that element is an indication that Avogadro's number will be used. We use our chemistry knowledge to ask what is in 1 mole of compound. The chemical formula tells us there are 3 moles of chlorine, or 3 times its molar mass, which equals 106.35 grams of chlorine in 1 mole of compound. Since there is 1 chromium in the formula, there is 1 times Avogadro's number, or 6.02 times 10 to the 23rd chromium ions in a mole of compound. To solve the problem, we start with the 4.50 grams of chlorine given and construct a conversion factor with grams of chlorine on the bottom and individual chromium ions on top. Calculation gives 2.55 times 10 to the 22nd chromium ions. In summary, we have done a variety of substance stoichiometry problems. Most textbooks will present the last problem we did as a complex 3-step calculation. By doing the chemistry part first and using our knowledge of what a chemical formula tells us in terms of moles, mass, and individual atoms and ions, we can boil the problem down to a 1-step algebra problem. That way, we know we are using the correct conversion factor and that we are using it properly if the original units cancel out.